Welcome to the fifth lecture of this series of lectures on kinetic theory and thermodynamics. This lecture hour will be essentially spent on describing the basics of thermodynamics, but as our regular practice is, I will be doing a little bit of recapitulation of kinetic theory of gas. What we did in the last lecture, we talked about mean free path and non-ideal gas. Both the things I will touch upon briefly before I move on to thermodynamics. So, we calculated the mean free path. What is this quantity? This quantity is the distance traversed by a molecule between two successive collisions. Since we are talking about kinetic theory, I need not remind you this is the average distance. And this quantity is actually given in terms of average velocity and time between two successive collisions, which we calculated, and that gives me the mean free path, which is 1 by n pi d square, where d is the diameter of the molecule and n is the number density. Now, here we assume that molecules are Hertz spheres with a diameter d. Then what did we do? We constructed a cylinder this is the height and this area is pi d square and molecular diameter is this d and this radius is d. Okay. Now, we draw this picture. This is the top view of this cylinder, if you like. This is the molecular radius d by 2 and this is the radius d of the cylinder I have constructed. So, what is important is whenever any other molecule, let me remind you that I assumed other molecules are static in the beginning. Whenever the center of any other static molecule comes here, tries to penetrate this cylinder, there is a collision. So, whenever any other static molecule has its center either on this line or inside, that is inside the bigger cylinder, there is a collision. Using this, we could calculate the total number of collisions in time delta t. Total number of collisions, we found out that it is n pi d square delta t. This is total number of collisions over a time delta t. From that, one can easily find out what is the time between two successive collisions and hence the mean free path, which has this form 1 by n pi d square. So, it is important that molecule has a finite size and that is taken into consideration while calculating this mean free path. Now, there could be many questions here. This target molecule, which I mentioned in the last lecture, it suffers collisions, though it